All right, what's going on, you guys? Another LeetCode video. This one is called subsets 2. So we're given an integer array nums that might contain duplicates, and they want us to return all of the possible subsets, aka the power set. The solution cannot contain any duplicate subsets, but it can be in any order. So this is very similar to the original problem subsets. It's a little bit different because the key distinction is that this problem, the nums array, can have duplicates. In the original subsets problem, it's guaranteed that all of the numbers are unique, so it's a little bit more straightforward. For this one, since there can be duplicates, it's a little bit less obvious how big the output vector should be, right? So we know, just as a rule, that the power set of a set is going to have a size that's proportional to 2 to the n, where n is the size of nums. That's when all of the elements are distinct. But for this, we can have duplicates. So basically what that's going to mean, since there can be duplicate subsets, or since there can be duplicate numbers, but there cannot be duplicate subsets, there's going to be less subsets than 2 to the n in our output array. So that's something to consider, but let's get into the whiteboarding. So we're going to solve this with recursive backtracking. So if we were given this example, so this is the example they gave us, it's 1, 2, 2. Basically, the first thing we're going to want to do in order to handle the duplicate numbers is we're going to just sort this in ascending order. So that's going to allow us to basically, while we're looping through these numbers, just have a condition and say, okay, is this number equal to the previous number? And that's basically going to allow us to skip over duplicate elements without adding much or any additional time complexity, right? So we can see basically if a number is the same and skip it just by comparing it to the previous element when the array is sorted. So we're going to sort this, and then we're going to seed our recursion just with the empty set here. So that's like the current subset. And then we're also going to have an integer here for the index that we're at. That's going to tell us where we need to start looping at each recursive call. So basically, for our recursion, we're going to try to add the first available number. So that's going to be 1. And then we're also going to increment that index. So that's going to be 1. So then for the backtracking, we're just going to remove this number from the vector and then add the next available one. So that's going to be 2. And then still incrementing this index. So now that's going to be 2. Okay, and then we're going to try to go this way, but what's going to happen is we're going to see that this 2 that we're looking at, that we're trying to add, is the same as the previous number, right? So we're actually going to not call recursion because of that. So we're going to avoid duplicates by checking, is this number that we're trying to add the same as the previous one? If so, then we're not going to do recursion. Okay, so let's go to the next level of the tree. So we're going to try and add the next available number. So that's going to be 2. So now this array is going to look like this. By the way, at each call, we're adding to our result set. So this is going to be a subset. This is going to be a subset. This is going to be a subset. And this is going to be a subset. Just adding those at each recursive call. So this is going to be incremented, so that will be 2. Okay, so let's try and do recursion this way. We're going to try to add, backtrack this 2 and then add the next 2, but we can see it's the same, so we're actually not going to do anything there. Now for this is where it gets a little interesting. So we would try to add that 2, and ordinarily we wouldn't be able to because it's a duplicate, but there's an exception here. So we're actually going to add the next 2 anyways. If this I is, basically if we're on the first iteration of the loop, we want to just go ahead and add the next number anyways. And that's like very important for this algorithm to work properly. So we're going to go ahead and add that anyways, because it's the first iteration here. And then we're going to increment that index like usual. Okay, so now this is going to go in the solution set. It's going to be one of our subsets in the power set. So let's continue with this. So we would actually there wouldn't be anything else to do here, so that's it. So let's do this. So we would go ahead and add the 2, and because this is the first iteration of the loop, even though the 2 is the same, we're still going to add it. So it's an exception. So we're going to add that 2 and then increment that index. Okay, and then that's going to belong in our solution. And we would, there's actually nowhere else we can go this way. So that's pretty much it for the solution. So, and we can see that there are 6 sets here, six subsets. So that's exactly the answer that they showed us in the input-output example. So in terms of the time and space complexity, the time is going to be big O of, it's going to be big O of 2 to the n in the worst case, right? Because the number, we're gonna have to visit every node in this recursive tree, right? And in the worst case, if all of the numbers are unique, then there's gonna be 2 to the n nodes in this tree. And then for the space complexity, it's just going to be big O of n. Because the height of this tree is going to be always at most going to be n, the number of elements in this set, because we're just building the power set. The biggest power set is going to be the same size as this input array. So, and that's going to be the height of the tree, so big O of n for the space for the recursive call stack. So let's go ahead and get into the code. So we're going to need a result, 2D result vector, right? So we should call this res for short for result. And then we also need a vector of integers for the current subset we're building. So that'll just be empty at first also. And then we can go ahead and I'll overload the subsets with dupe function and just return the result. So let's go ahead and write that function. So I'll write it as implement it as a private class method. It'll be void, and we'll just call that subsets with dupe. And then it's going to have some different parameters, right? So it's going to have that vector of integers that result by reference. It's also going to have a vector of integers by reference. That's going to be the subset, current subset we're building. And then we need a vector of integers by reference for the input vector, so nums. We also need an index I. That'll be scope specific to each recursive call, so not by reference. And then let's see, so res subset nums I, and that should be everything. We might need more, but if I remember anything else, then we'll add it. So let's go ahead and seed this now that we know what the parameters are. So let's just pass in res, that subset, nums, and then the index first. That can just be 0. So the first thing we need to do, remember, and I didn't do this yet, is we need to sort. And also, yeah, so there's one thing I'm forgetting with the time complexity, right? Because I totally forgot about the sort operation. So this time complexity is also going to be, we have to account for sorting. So this is going to be plus in log n for sorting, right? Because sorting in C++, the built-in function is just going to be in log n time. So a little bit of an oopsie, forgot that. That's pretty important. So sort, we're going to sort from the beginning iterator of nums to the end iterator to sort in ascending order. So num.begin and then .end, and that will go ahead and sort it. So then what we want to do is every time we call the recursion, the first thing we can do is just go ahead and add the subset to the result. So res.pushback subset, and then we can go ahead and do our for loop. So we're going to loop from I to nums.size. So we'll say j equals I, while j is less than nums.size, and then j++. And then we're going to have our special condition. So if so we only want to have this condition where we're skipping over duplicates if we're not at the first iteration. Remember, right? That's the first iteration's the exception. So so we're going to say, to make sure we're not at the first iteration, we'll say if j is greater than I, and now we can do the comparison. So if nums j is the same as nums j minus 1, so the previous element in nums, then we can just go ahead and skip by saying continue. So that'll skip this iteration, it'll skip that number. So otherwise, we want to add the current number to the subset. So we'll say nums dot, or it's actually going to be subset dot push back on nums j. Then we can do the recursion. So subsets with dupe, and then we pass in those parameters. So res subset nums, and then we are going to increment j+1 for the index, and then we'll do the backtracking, and then that's it. So it's just subset dot pop back for the backtracking. That's pretty much it for the code. So let's go ahead and run this. So hopefully this video helped you understand the problem more. If it did, leave a like and subscribe, and I'll see you guys in the next video. Peace.